Okay, yes. In the last class, we stopped here, right? We were discussing about 2D transformations. So we discussed about three basic type of 2D transformations. So one was translation, one was rotation, and another one was scaling. Fine. So we came up with the equations for those things and the respective new coordinate, how to find the new coordinates, right? So for the translation, it was p dash is equal to p plus t, and this is how I was supposed to find the new coordinates for my translation, right? So x dash is equal to x plus tx, y dash is equal to y plus ty. On the same lines, coming into rotation, my general equation was p dash is equal to r into p, and my x dash was x cos theta minus y sin theta, and y dash was x sin theta plus y cos theta. And coming to scaling, it was p dash is equal to s into p. Fine, right? So where x dash was x into sx, that was sx was the scaling factor, then y dash is equal to y into sy, so sy was the scaling factor, right? So next thing we need, as any image, if I take, it may be any pixel or it may be any point, right? So inside the computer, how it will be represented? It will be represented using the matrix form. Fine, right? Any image, any point, any pixel, anything, right? So anything with respect to image, it will be represented in the computer in the form of a matrix. Fine, right? So now coming to these things also, coming to translation, coming to rotation, coming to scaling, right? So all these things also, I need to represent them in a matrix form, right? So then only my frame buffer can read it and it can display it. So my next concept is how to display these things, right? Translation, rotation, and scaling, right? These things, right? That is calculation of new x dash y dash with respect to translation, with respect to rotation, and with respect to scaling, right? So these things in the form of metrics. That is my next concept. Fine, right? So now coming to this, right? Metrics representation. Okay, fine. Yes, this is matrix representation, right? So each of the three basic two-dimensional transformations, that is translation, rotation, and scaling, right, can be represented in the general matrix form with this general matrix form, right? That is p dash. P dash is nothing but my new point x dash y dash, that is equal to p. P is my old point xy into m1 plus m2. Okay, right? So now keep in mind this equation, and we shall see how this equation can be used to represent all my three basic transformations, that is translation, rotation, and scaling into the matrix form using this particular equation. Then I will describe what are these things. Fine, right? Now let us come to the first let us come to the first one, that is translation, right? Coming into translation, we know the equations for new x dash and y dash. So the new equations for x dash and y dash is x dash is equal to x plus tx and y dash is equal to y plus ty, so which I can represent in the matrix form like this. Okay, x dash, y dash. So x dash is equal to x plus tx and y dash is equal to y plus ty, right? So now x dash is equal to, right, how will you multiply, right? So this is a this is a column matrix. X dash, y dash is also a column matrix. X, y is also a column matrix. What is a column matrix, right? Column matrix means which has columns which doesn't has any rows. Okay, right? So is x dash y dash represents p dash and x y represents p. Okay, right? Both p dash and p, always it will be a column matrix. Column matrix means which has only columns, which doesn't has any rows, right? So now here coming to this, in the matrix form, x dash equal to x plus tx, y dash is equal to y plus ty, right? So I will substitute this to my general matrix equations what I have, that is p dash is equal to m1 into p plus m2. Fine, right? So here p dash is x dash y dash, right? So now my p is x y and into m1, right? M1 is identity matrix here, right? So identity matrix means, right, which doesn't change, which doesn't change the value of my actual thing, right? That is what identity matrix. So m1 will be identity matrix in translation, right? And tx ty becomes m2, right? So coming to my translation, what is x dash y dash? It is p dash. These are column metrics. Okay, right? And coming to my translation, m1 is identity matrix. Okay, and coming to this tx ty becomes my m2, right? This is how I will reduce this or I will deduce my translation metrics or my translation equation into my matrix format. Okay, is this clear? Right? So now coming to the next parts, that is rotation and scaling. Okay, right? So now coming to rotation, what is the equations for rotation? X dash and y dash. So x dash is equal to x cos theta minus y sin theta, and y dash is equal to x sin theta plus y cos theta, right? So now how to represent this in the matrix form now? Okay, x dash y dash I know, right? This is x dash y dash, right? So now x cos theta minus y sin theta and x sin theta plus y cos theta, this I need to represent in the matrix format, right? How do I represent this in the matrix format? Using this way. Okay, right? Cos theta minus sin theta, cos theta into x, y. Okay, right? So now let us see here what happens, right? So x cos theta minus y, x dash is equal to x cos theta minus y sin theta. I got this. Now y dash is equal to x sin theta plus y cos theta, right? So this x cos theta minus y sin theta, x sin theta plus y cos theta, right? I have converted that into matrix format. Okay, right? Where my p dash is a column matrix which has two columns, x dash y dash, and doesn't has any row, right? My m1 is a 2 cross 2 matrix, right? It has two rows and two columns, right? Into p is again xy, my old x and y, right? Which is again a column matrix which has two columns and which doesn't has any row, right? Plus m2, right? So here plus, what is this additive matrix? There is no additive matrix, right? So this plus m2 will be 0 here. Okay, right? This is how I have converted this general equation p dash is equal to m into p plus m2, m1 into p plus m2, right? For the rotation matrix. Okay, right? So now cos theta minus sin theta cos theta, right? Is please
cos theta, sin theta. ನಮ್ಮ ಅಣ್ಣ ಬಂದ
okay, is cos theta minus sin theta cos theta, right? This becomes m1, right? That is my rotation matrix into p is x y plus m2, right? There is nothing for m2, so what we will do, we will keep m2 as 0. Okay, fine, right? So now on the same lines, right? Coming for on the same lines, now coming for scaling. Okay, right? Scaling, we have formula for x dash and y dash. So x dash is equal to x into sx, y dash is equal to y into sy, right? So now x dash y dash, I know x dash y dash is nothing but my p dash, which is a column matrix, right? So now this x into sx, y into sy, I need to convert that into matrix format, right? So why we are going actually for this matrix format? Because, right, any image in my computer, it should be represented in the form of matrix. It may be any pixel, it may be any vertex or anything, right? A smallest image, what I can say is a vertex or a point, right? So even that should be in the form of matrix for my computer to read that, right? So all my things, I'm trying to convert everything into matrix. Even these transformations, I'm trying to convert that into matrix format, right? So now coming to the matrix form, this x into sx, y into sy, right? uh, Fine, right? So this, how I'm doing, I'm converting like this. Okay, right? I'm converting like this way, right? So where, right, x into sx, y into sy, this is what I have converted that into matrix, right? Where sx 0 0 sy, right? So what happens to this, right? So sx into x dash is equal to sx into x plus 0 into y. So 0 into y will be nothing, so x into sx, right, into y dash is 0 into x plus sy into y plus y into sy. Fine, right? So this
Yeah,
also,
yeah. All right.
please mute your
Okay.
microphone.
Yeah.
Just mute your microphone, right? So this is also same thing. P dash, this x dash y dash is equal to m1. This is scaling matrix. Okay, m1 is this one, right? This is what we call it as scaling matrix, and this m1, right, for rotation we call it as rotation matrix. Okay,
Yeah,
right?
yeah, bro.
So m1 into p is xy
It's
plus
not that
m2.
there's the family slash in the M2 section and all. It's like I have been in a trip like I'm going highway and all. It's like, bro, where's the Tia? I'm looking for Tia. What the fuck you doing in class?
Okay, right? So this is scaling, right? m1 into p plus m2, where m2 becomes 0, right? So now coming to next part, right? Applications of this. Okay, right? So where are the applications of these transformations found, and what is the difficulty that is faced, right? So one important or one common the applications of this particular transformation is, right, you may find it in movies, right? So the introduction of a movie, they will show you, right, if any person is coming from abroad or somewhere, right, they will show you, right, from India, right, some flight or some picture will move from India to any other country, right? So movement of that, what they show is translation, correct, right? They are moving something, right? So translation, fine, right? And after, as soon as they go there, right, inside that country, they try to scale it. That means, right, they try to go inside that country, inside to the particular state, inside to some city, right? That means they are applying transformations there. Okay, in the animation, what transformation they are applying, right? Moving from one place to another place is translation. And from there, if you may find it, right, some rotation like of things or some scaling type of things. Scaling type of things means, right, so if they show America, right, from America, right, they may show one of the states of America. In that state of America, some street, in some street, that person, that is scaling, right? That means, right, so there may be some situation where I need to apply multiple transformations, right, for an object. Fine, right? So that means multiple transformations means for that same object, right, I may need to apply translation for the same object. After translation, I may need to apply rotation. After rotation, I may need to apply scaling, again translation. Like this, I may need to apply for the same object, right, for this, for the same object, right, I may need to apply many transformations, like translations, rotation, and all those things, right? So let us see what happens at that time. Fine, right? Now let us see, this is my first object pxy, right? I will apply translation to that. That becomes p dash of x dash y dash, right? I'm getting new x dash y dash, right? This is intermediate one. Again, I need to apply rotation for that. When I apply rotation, again I will get p double dash x double dash comma y double dash, right? Actually, what I wanted, right, I wanted from this pxy, right, to this. That means for this p point p, right, I need to apply translation and also rotation. That means what is the final result I need? I need this p double dash, that is x double dash y double dash. Okay, Fine, right? So this was what I was supposed to. This was what I was. Yes, this is what actually I need from this to this, right? But as for we know, as for I know now, as of I know, right, what I need to do, first I need to provide translation. After getting new translation coordinates, for that coordinates again I need to apply rotation, then I will get the rotated object, right? So instead of that, can we have some method, right, so that, right, from to the actual points, right, I will apply both translation and rotation and directly get the final result without getting this intermediate x dash y dash, right? I can get can I get any final result? Okay, right, that is what I am trying to do now, because, right, from pxy I will get p dash x dash y dash, right? For that p dash x dash y, for that p dash x dash y dash, again I need to apply rotation, then again I will get this thing, right? It is simply a waste of time for me. Okay, right, this doing this thing. So I'm trying to have a concept where from pxy I will apply translation and rotation function for this pxy directly, so that directly I will get this p double dash x double dash y double dash, right? So now to do that, what is the problem is, right, my translation has additive metrics and my rotation and scaling has multiplicative metrics, correct, right? Which is difficult to solve mathematically. That means, right, if I want translation, right, I need to, if I want translation, I need to go for additive metrics. Okay, right, that means I need to add the metrics, right? If for the same thing again, if I need to, if I want rotation or scaling, I need to go for multiplicative metrics, right? So now having addition, having multiplication, right, both are having both of these things, right, requires more complex hardware, right? So what they found out is, right, is there any way, right, so that I can reduce this multiplication addition to a single operation, whether multiplication for all the three or for or addition for all the three, right? So what they found was, as for rotation and scaling, I had multiplicative operations, right? So I tried to provide multiplicative operation for my translation itself. Okay, right, removing this additive metrics. Fine, right, that was what they actually needed, right? So because I'm having additive and multiplicative metrics became more complex for us, so now those things, right, solution to have a single type of matrix operation for all the three types of transformations, that is single type of matrix operation means either multiplicative operation or either additive operations, right? So we went for multiplicative operation because, right, hardware for for providing that multiplicative operation was cheaper, and also for for additive operations. For only translation I have additive operations, so I tried to remove that uh, additive operation for translation, and I also try to provide these multiplicative operation for translation also, right? So to do that, right, so they came up with a new concept called as homogeneous coordinate system. Okay, right, this is a very important question, right? So homogeneous coordinate system, why you need this homogeneous coordinate system, right? You need this homogeneous means single type of, right? That means single type of operation I need to require for, I need to do for all the three transformations, so that it becomes easy for to do this, right? So fine, right? So now what they did in this homogeneous coordinates is, right, so multiplicative and translation terms of a two-dimensional geometric transformations can be combined into a single matrix. That means multiplicative and also translation means additive operations of a two-dimensional geometric transformation can be combined into a single matrix if we expand the representation to 3x3 matrix. What was my matrix? It was 2 cross 2. Okay, right, that means I had two columns or 2 cross 2 matrix, that's it, right, for translation, for rotation, and for scaling. Now they say that, right, if I want a single operation for all the three, I go for 3 cross 3 matrix, I need to convert this 2 cross 2 matrix to 3 cross 3 matrix, so that I can provide a single type of operation for all the three types of transformations, right? Given the coordinate is okay, use the third column for transformation matrix, right? For the translation terms and the transformation equations can be expressed in matrix multiplication, right? That means this transformation equation I need to express that in multiplicative matrix multiplication. So I will use the third column, that is in 3 cross 3. I will use the third column for doing this. Fine, right? Now let us see how to convert this two-dimension, two coordinate system to 3 cross 3 coordinate system. Okay, fine, right? Yes, now see here. Okay, right? So two-dimensional coordinate system, right? So where I have x comma y, right? Now I need to convert that into three-dimensional one, because I need a single type of operation, that is homogeneous coordinate system. So what I will do, I will multiply this x by h, y by h, and for the third coordinate I will be having only h, xh, yh, h, right? So that is nothing but, right, that is equal to new coordinate, I call it as x h, y h, and this is h, right? So now, so what is x, right? So xh is equal to this xh, yh is equal to this yh, and this h is equal to this h, right? So what is my x becomes, my x will become xh divided by h, and y becomes yh divided by h, right? So now my x, if I want my new coordinate xh to be equal to x and yh to be equal to y, what should happen? This h should be equal to 1, right? As we want x is equal to xh and y is equal to yh, we make h is equal to 1, right? That means my third coordinate which I am using, I will always be treating that as 1. Okay, right? So that is the concept of homogeneous coordinate system. Okay, fine, right? So yes, now coming back to our presentation, right? We can use this third column for translation matrix. Yes, we also need to expand the matrix multiplication of two-dimensional coordinate position to three element column matrix. Okay, right? So what happens? X is equal to xh by h and y is equal to yh by h, right? What I shown in the word slide, right? A standard technique for accomplishing this is to expand each of these two-dimensional coordinate position xy to a new three-dimensional coordinate system xh, yh, and h, called as homogeneous coordinates, where x is equal to xh by h, y is equal to yh by h, right? So this to make x is equal to xh and y is equal to yh, I will take this h is equal to 1, right? So that means, right, so always my three coordinate system looks like this: x comma y comma 1. Okay, this is an important question that they will be asking you, right? So explain homogeneous coordinate system. Okay, right? Question: explain homogeneous coordinates with translation, rotation, and scaling. Okay, right? Explain homogeneous coordinates with translation, rotation, and scaling. Okay, so this is the explanation that you need to give the homogeneous coordinates, and let us see how homogeneous coordinates, right, will be in terms of translation, rotation, and scaling. Okay, right? Come to this translation, two-dimensional translation matrix, right? So what was there in two-dimensional translation matrix, right? It was x dash y dash, that's it, right? So now this is a homogeneous coordinate system where I'm converting this additive matrix which was there in the translation for 2D into multiplicative matrix, right, in homogeneous coordinate system. That means by expanding one coordinate, right, I'm converting that additive to multiplicative form for my translation, right? That is in this way: x dash y dash and 1, h is 1, right? This is my third coordinate will be always equal to 1, which is equal to, this is my translation matrix into x comma xy 1, right? Now what happens? X dash is equal to 1 into x plus 0 into y plus tx. I got the same thing, that is x plus tx. Y dash is equal to y plus ty, and x, that is what I wanted, right? I got this, where I converted this translation, right, into multiplicative, so that only one type of operation remains for me to do multiple transformations for any object. Now on the same lines, coming to two-dimensional rotation, right? So two-dimensional rotation in homogeneous coordinate system, right? That is three coordinate form, right? X dash y dash 1, right? X dash y dash 1 is equal to cos theta minus sin theta. That is, I will add a identity matrix here, right? 0 0 1 0 0 1, right? Into x y 1, I will get the same thing, right? So x into cos theta minus y into sin theta, x sin theta plus y cos theta, right? This is the identity matrix that I have, and this is 1, this is 1, right? So homogeneous coordinate means you always remember that two coordinate will be converted into three coordinate system, right? Why I need to convert the two coordinate into three coordinate system? Because I want all the transformation function, that is translation, rotation, and matrix, to have a single type of operation. As we have translation in terms of additive, right? So I need to convert that additive also to multiplicative form. So I convert actual form into homogeneous coordinate system, that is a two coordinate system into three coordinate system, and I will make this translation also additive, sorry, multiplicative, right? On the same lines, coming to scaling. Scaling, right? Two-dimensional scaling matrix also. The scaling transformation relating to coordinate origin, right, is expressed in the matrix multiplication. So this was already in matrix multiplication. So I'm just converting that into three coordinate system, right? So x dash y dash and h is 1, right, is equal to sx 0 0 0 y 0 0 0 1, right? This doesn't change anything. Sx into x plus 0 into y plus 0 into 1, that is x into sx. So here also 0 into x plus sy into y plus 0 into 1. So y into sy, x dash and y dash remains same thing, right? So this is what we are converting two dimension, two coordinate system into three coordinate system, that is homogeneous coordinate system. Homogeneous means, right, all these things looks same now, right? So x dash y dash 1 is equal to this into multiplicative. So here also x dash y dash 1 is equal to rotation into multiplicative into p, right? And the same thing applies for scaling also, right? P dash is equal to the scaling into p, right? So now if I want to apply a single for a single object, if I want to apply more number of transformations, right, then this now becomes easy for me to apply. Okay, right? So this is what about today's discussion, right? So the important question that comes in today's discussion is this, right? Explain homogeneous coordinates with translation, rotation, and scaling metrics. Okay, with scaling metrics, right? Explanation of homogeneous coordinate system, right? So multiplicative and translation terms, additive terms of a two-dimensional can be combined into a single matrix, right? So by expanding the representation to 3 cross 3 matrix, that is 2 cross 2, I'm expanding that to 3 cross 3 matrix, where the third column is for my translation equation to convert that into multiplication. Okay, right? And then this is the explanation for that, right? So now two-dimensional translation matrix, this translation matrix in the form of homogeneous coordinate system, this one, right, where p dash is equal to t, that is tx and ty into p, t plus p was there, now t became t into p. This was same thing, p dash is equal to r into p, and the scaling is also same thing, right? P dash is equal to s into p. Okay, right? So this was about today's discussion, right? Tomorrow we will discuss about inverse transformations, right, and composite 2D transformations. Okay, thank you. The session will be ending here.